Go so that we can share this with people who aren't with us today. So, um, I'm seeing one, two, three, four, five, or
Hey,
how many are there? Hi,
there
Lucas.
is one, two, three, four, five, six, seven, seven of us.
Okay. All right.
Uh, in the classroom though. Mr. Cordy, Travis Woolsey wanted me to ask you to record this as well, just because
Great.
he's not going to be here. He's got something going on.
Yeah, yeah, no problem. No problem. I think Dr. Stone told me he works for the water department or something.
Yeah, he works for the Greenville Water Department.
Yeah. I can imagine they're pretty busy right now. So, um, all right. So yeah, so this will be recorded so other people can see it later on. Um, and if you want to go ahead and fire up Octave while I'm making introductory remarks, we're going to sort of do some Octave at the same time we're talking about static stuff today. Okay. So we're going to get to kind of see how Octave can work to make our lives a lot simpler. Okay. Um, so what we're going to be doing today are um, moments in 3 dimensions. Okay. And so, like, Marcelo asked a question, I don't know, a few days ago about the homework with moments, and I asked him to send me a screenshot, and he sent me a picture of his notes, and I noticed he was doing the full cross product treatment. Okay. Which is totally fine, which is totally fine. Anybody else do that with the last homework assignment? Just go straight to cross products. Okay, so Spencer, Mary, did I see your hand? Yeah, I don't know. Okay. Oh, here comes Zulki slinking in. Okay. All right. Okay. So that's fine. It's totally fine to do it that way. And like if we have a test and you want to do it that way, I don't care. I don't care. Okay. With the two-dimensional problems like that that might be overkill, but it is very straightforward. And as long as you set everything up, you don't really have to take on too much um, in terms of mental processes. You can kind of plug and chug and boop, your answer pops right out. Okay. So let me do a screen share and we will get into it. Okay. Do a portion of the screen. Put myself. Well, can I do that? This over here. Ah, interesting. All right. So I'm gonna be a little talking head today. Okay. And we go. We grab this for us. Well, I'll just do it down here. Okay. Boom. All righty. Okay. So here's a couple of problems, and these are a pair. They're both based on this image right here. Okay. And I just want to remind you again, those of you taking notes, um, these slides are all in eLearn, and our pictures and stuff, our diagrams are just going to get more and more complicated. So if you want to print those out ahead of time and bring them to class, that might be a really helpful idea. Okay. But if you enjoy drawing, that's fine. Okay. So our situation here in the first one, it says, determine the magnitude of the moment of the force about the x-axis. Okay, so let's dissect this. See what is going on here. Okay, so first of all, get some better colors going so you guys can see them. We want the magnitude of something. Okay, so we're looking for a scalar result. All right, of the moment. Okay, now the moment is a vector quantity. Okay, of the force about the x-axis. Okay, so this is kind of like a projection. Okay, so what we're going to end up doing is we're going to end up finding the moment. Okay, and then we're going to project that onto the x-axis. All right, so that's the plan. Now, what that's going to give us is it's going to tell us something about how much our little force down there is trying to twist the pipe structure um, with regard to the x-axis. Okay. So if you take a look at O there, and I hope this shows up good in your picture, but it's like a pipe fitting. Okay. It's like the pipe is screwed into the wall. Okay. So here's what I want you to do. I want you to talk this over with your neighbor. The force right there where it is that going to cause those threads at O to stay tight? Or over time, is it going the other way where it's going to kind of loosen them over time? Okay. So talk that over with your neighbor. Let's kind of share some ideas. All right.
Wait, can you say that again about the threads?
Yeah. So the pipe is like, there's a mount on the wall there where the pipe is threaded into that mount. Can you tell
Oh, so
that?
you're just wanting us to figure out if it's going to tighten up as that force is applied or it's going to loosen.
Correct. Yeah, exactly.
Okay.
All right. Well, let's see here. Who's got an idea?
Yeah, I think it's going to tighten up.
You think it's going to tighten it up? Okay.
Mm-hmm.
All right. So let's, can we do like a little poll or something? Sir, what can you like do reactions or something and give me a thumbs up if you like? Okay, we'll do it for realsies. Okay, everybody thinks it's going to tighten up. Okay. All right. So we're going to chase the math on it and find out if that's really the case or not. Okay. Um, so what we need to do in this case is, well, we got the force. Okay, well, that's good. All right. But we need a moment arm. Ugh. Okay. So we got to go from somewhere to somewhere. Okay. So in the first homework set, it would be like, find the moment about the point O or find the moment about the point A, right? This one doesn't do that. Okay. But it does say about the x-axis. Okay. And so that's this axis right here, of course. All right. And so what we're going to do is we're just going to go straight from the origin here out to the point of application there. So we're going to say that that is our moment arm. right there. Okay. All right. So we need an expression for that. Okay. So R, all right. That is, it's right down there. So it's forward in X. It's for, oops. Yeah, no, that was correct. It's, nope, it's not correct. Just kidding. Okay. Point three, it's forward in Y and it's down in Z. Okay. So that's our R vector. All right. So to get our moment, what we're going to need to do then is go R, cross it with F. Okay. All right. So I'll let you work that out with your neighbor. Got it. Did you guys get it? Okay. Now I didn't say you could use Octave, but we got it pulled up, right? So we might as well. Okay, Lucas has put in there 2105, 180. Good. All right. Lucas, did you use Octave or did you crank that baby out by hand?
I actually used the program on my calculator I built.
Sweet. Awesome. Very nice. Okay. So you're welcome to use Octave or your calculator, okay, on any of these as well. Again, though, like I've said before, you need to know how to do it by hand also, okay? Okay, all right. So let me go back here. All right. So we've got that, and that turned out to be 2105, 180. Okay. Switch things here. Okay. Now, Mary asked a really good question. Why do we cross and not dot? Well, by definition, the cross product, sorry, the moment is a cross product. The moment is a cross product. Okay. So that's why we want to do that. Okay. Now, what we did before was we used the scalar definition, all right, which is to say that M is our F sine theta. And that's when we had to mess around with clockwise, counterclockwise, positive, negative. We don't need to mess around with that stuff here. We just put it in our cross product, pop that baby right out. Okay. Now that's just the moment though, right? That's just the moment. Okay. And but we need the moment about the x axis. Okay. So if I think about that moment that we've got right here, there is an x component, a y component, and a z component. Okay. And so it's not very much x. It's mostly negative y and negative z. So I'm not even going to try to draw it on there. Okay. Because it's just gonna get messy and I don't think it'll help, to be real honest. Okay. And so we can see right here then that our it turns out that what we're looking for is this guy right here, 20. Okay. That's what we got there. All right. Um, so were we correct? Is that gonna tighten or loosen it? Talk that over with your neighbor. Make sure you got to do a little geometry with your hand. Okay. Okay. Oh, Gerardo saying loosen. Okay. Anybody else like that? Loosen? Want to switch? Oh, Gerardo, they're leaving you hanging, man. Can you tell me why did you decide to change and go with loosen?
Because I saw that it's a positive moment, which makes it counterclockwise movement, which would be loosen.
Very good. That's correct. That's correct. All right. So if you do this thing with your hand, right? Okay. So if I have a rotation like this, all right, then my thumb is going to be the vector that describes that direction. Okay, like this. And in our case, we know it's along X. So that means since I know this direction, I know this is going to be the rotational effort. So this is my moment right here. And that's going to try to loosen this thing. Okay. Now, what's deceptive here, and the reason our instinct right off out of the gate said that it would tighten it is just because looking at the drawing. Okay. Now, if you look at the drawing, though, the things that matter for the X direction are this component and this component. Okay. So in terms of rotating around X, that Y component has a very small moment arm. Okay. It's a very small moment arm that's going to try and make that thing rotate around X. So we're not going to get much moment out of that thing. Okay. But the Z component, okay, is actually like here down here. Okay. And whoops, except it's positive. Not bad. Okay. It's actually positive, so it's up here. All right. And that is going to make this thing around X try to go like this. So the X component and the Y components are in opposite directions once we look at their moment. Okay. Um, about the X axis. And so it ends up that Z component, because the moment arm, which is the 0.4 here, is so much longer. Okay. Now, if that's if you're having a hard time getting your head around it, that's okay. I mean, these three-dimensional things are very difficult to visualize and try to understand. Okay. But what Gerardo said, okay, future Student Association president, is that because it's positive, it's got to be counterclockwise. Okay. So you can fall back onto that. Okay. All right. Take a look. I'm going to undo some of this. And you guys take a look at the next one. What's different or the same about it? Okay. Talk that over with your neighbor. Okay. So let's see here. Mary, what's one thing that's similar? Yeah, very good. All right, good. Travis, what's another thing that's similar?
Would it be like the XY plane in which the axis lays on?
Oh, that is similar. Yes, that's true. Yes, that's true. Good. Um, outside of that, the only thing that's similar is that they're both basically the same question, but they're different. It's a different axis, right? That's the main thing that's different. Okay, instead of X, we got the OA. Okay. And so if we do that, we take a look at that, then oh my goodness. Here is here is OA coming through there like that. Okay. Now, before we actually do that, I want to point something out. When we said the blue vector R is there, okay, we could have made it over here, over here, over here, over here. Okay. We could have picked any of those, any of those. Okay. So I'm going to do this just for fun. Let's say we go from here down to here. Okay. And so that's going to be a different R. Okay. So that's going to be, I'm not moving in X at all, but I'm still moving 0.4 in Y and minus 0.2 in Z. Okay. Like that. Now, what I'm going to do, I'm going to come back to my octave so I can do it quickly. Okay. And I want to show you what's going to happen here. Okay. So I've got the same F. I'm going to redefine R. Let me call it R2, just so I don't get confused. I've got 0, 0.4 minus 0.2. Okay. I'm going to say M2, and that's going to be cross product. Oops. Of R2 with F, like so. Okay. And there it is. Okay. Now, take a look at my original M. I'm sorry, it's really small. I can't make that any bigger. It's 20 minus 105 minus 180. Okay. For when I put R somewhere else, I get 20 minus 60 minus 120. So it's a completely different vector and it's got a completely different magnitude, right? But what's the same about those two things?
The X.
Yeah, the X is the same. So if I just pick out the X component, it's the same. Okay. So that what that means is when we're doing these, okay, um, we want to set our moment arm from the axis of rotation. Okay, the axis of interest. Okay. So any of those blue vectors would have worked to give us the same. It'd still be 20. Still be 20. Okay. Now let me clear out some of this stuff because my drawing has gotten pretty messy. Okay. So what we learn is I just need to go from the axis of interest down. Okay. So why not start at A because that's on the axis, right? And let's just come down like this to my point of application. So I'm going to call that R3. All right. It's not going anywhere in X or Y. It's just going straight down. Okay. Now I'm going to do the same thing. I got the same force. Okay. So I'm going to pull back up to my octave here. I'm going to put a new R value in here. So I'm going to have R3, and that's going to be 0, 0, minus 0.2. Okay, there we go. All righty. And I need the moment, so I call it M3. Same force. R3. Oh. Boom. There we go. Okay, so what we find then is our moment. Let me call it M3. Over here becomes minus 40 minus 60. 0. Okay. Now, thing is, we want about the OA axis. Okay. So kind of like before. All right. Previously, all we had to do is go, oh, there it is. Woohoo. Okay. But what we could have done is we could have used the dot product, okay, to find that component. So we could have gone mx is m vector dotted with I unit vector. Okay. So what that looks like then, sorry, it's getting a little messy here. I'm going to do it up here. What that's going to look like is I've got my 20 minus 105 minus 180. And I'm going to dot that with 100. Okay. And then hopefully you can see what's going to happen is I'm going to multiply 1 by 20, which is going to get me back a 20. Well, that's a 0. That's not going to do anything. And that's a 0. So that's not going to do anything. So I'm just left with the 20. Okay. So what we're going to do then is we want to have MAO. Okay. So I'm going to call it M3OA. Okay. And so what we're going to do then is we're going to take M3 and we need to dot it with a unit vector along OA. And it's going to do the same thing for us. It's just going to pull that out. Okay. And that's going to tell us how much of our moment is actually along OA. Okay. All right. So with your neighbor, I want you to figure out what's OA and what's the unit vector in the direction of OA. Okay. So two things for you. Find OA and then find the unit vector that corresponds to that. Okay. Did you get it? Okay. Once you've got it, go ahead and do the dot product. Okay. Oh, okay. So Marcelo's put minus 24, minus 48, 0. Okay. What's that number, Marcelo? Tell me what is that? Okay.
I'm sorry, what'd you say?
Well, I wondered what you had there. M30A 2448. So keep in mind, guys, that when we do a dot product, it's a scalar quantity.
Oh, right.
So you probably need to add those things together. Yeah, that looks better. There we go. Okay, Lucas got also negative 72. All right. Okay, now it's negative. All right. So let's do this thing with our hand, okay? Um, so we defined OA as going from O to A. So the positive direction is coming out of the screen towards you. All right. So if we had something rotating in the positive sense, or the moment in the positive sense, it would be going around like this. Okay. And that doesn't make any sense. However, our number is negative. So we turn that baby around. And now look at that force. And it's like, oh, that makes sense now. That makes sense. Okay. Okay. So let me do it. Let me do all that in Octave so you can see what that looks like. All right. We've already found M3 there. We need OA. Okay, so I'm gonna go OA. And we said that was 0.3.40. Okay. And we need its magnitude. Okay. Now remember the way we pull that off is we're going to do the square root of the dot product of the vector with itself. Like so. Boop. Okay. And I mean, obviously this is just a 3, 4, 5 triangle, so we didn't really need to do that, but there we go. Okay. And so then my unit vector for OA is going to be OA divided by OA magnitude. Okay, and there you go. We got that. Okay, now what we're going to do is we're going to go to the dot product of M3 and UOA. Look at that, minus 72. Okay, so in the chat, give me some digits. Okay, how are you doing? 1 to 5. Okay. All right. Okay, that's pretty good. That's pretty good. Good. We're gonna do some more of these, and I think it's gonna bring it home for you because they're not really any different. All right. Once you got your head around this, it's kind of like, okay, same song, um, second verse. Keeping up with the octave stuff is a little hard. Yeah, I know. I know. Especially since you can't see it very well. But here's what we're gonna do though, Gerardo. Okay. So everybody go ahead and go to your octave. Okay. And what we're going to do is we're going to come over here to this tab called Editor. And I've zoomed mine in, hopefully to make it a little easier for you to see. Okay. So you're going to have a bunch of these problems to do. You know that in your heart, right? And you're thrilled, I'm sure. So how can we use Octave to make our life a little bit easier? Well, we can write a script to do these calculations. Okay. Something that we can modify really, really easy. All right. Okay. So what we're going to do, okay, is the first thing we're going to do is we're going to do a save as. Okay. Save as right here. All right. And then we got to find a place to put it. Okay. So on your computer, you figure out where you're going to keep track of that. And you can see here, I've got lots of embedded folders, boink, 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 boink. I got to go all the way down, all the way down, all the way down. Okay. And so we need to give it a name that later on when we look at it, we're going to know what it is. Okay. So we're going to say, let's call this moment underscore about underscore axis. Okay. Underscore 1. Because we might need multiple copies. Okay. Now, Octave is a little old school, so it doesn't like to have spaces in the names of the programs. Okay. So that's why we got to do the underscore stuff. Okay. Then I'm going to hit
So,
save.
you hit the save as button and made a file name for it, correct?
I did. Yeah.
Okay.
And then you're going to have to figure out where you want to put it on your computer, Lucas, once you do that. Okay. Okay. All right. Now, this is going to be really simple. Okay. But it's a good time to get into the habit of doing some things. Okay. The first habit of doing things we want to develop is reminding our future selves of what we've done. Okay. Because you're going to be, we're having some project, you're going to work on it, you come back a week later and you're going to be like, what was I doing? Okay. So learn to be kind to your future self. Okay. So we're going to say here that this is we can say program or script. It doesn't matter. Okay. To determine the magnitude of a moment. Okay. And I'm running out of space there on mine. You can do all this on one line on yours if you want to. I'm just going to hit enter. Of a moment about a specified axis. Okay. Just like that. We can leave a blank line. It doesn't care. It's not sensitive to that. Okay. Okay. And then if this was more complicated, we might write a lot more about what this is going to do and how it's going to do it. Okay. This is not only important for you and save you time, but in your career and as you're doing things, you'll be doing them as part of a team. Okay. Or somebody else will be helping you, or somebody else will want to know what you're doing. Okay. So another set of eyeballs needs to be able to look at this and go, oh, I see what they're doing. Okay. So don't make them guess, because then they'll be pissed off. Okay. And you don't want to do that. Okay. Okay. The next good habit we want to do is to write the word clear. All right. Because what that's going to do is it's going to get rid of all of the previous variables and their assignments. Okay. If you don't do that, what can happen is you might run the program, and then all of these variables get assigned a name. Okay. And then you maybe change the name, but don't do something else. And it can cause some trouble because it's not going to forget that A has a value of 3 or something like that. That goes into the memory for the program. Okay. And every time you run it, it's going to assume that A is 3 unless you do this right here. Okay. So this is kind of like starting with a blank desk. Okay. So every time the computer runs, it's going to clear out everything and start fresh. Okay. So what we're going to do next, okay, is we're going to say, okay, all right, we're going to say input the moment arm, force vector, and the axis. Okay. So for the very, let's go back to the very first one we did. All right. The moment arm is 0.3, 0.4 minus 0.2.
How are you getting your stuff to be green?
Is yours not green?
No.
Did you put the little percent thing there?
No, I put something else.
Ah, there you go. So this is the editor, okay? And when you put the percent, it's just a comment. It doesn't mean anything for the program. It's just for us. And this editor is designed so that when you put a comment in, it turns green. So it's easier to see what it is. Okay. So there's R. Okay. And now we need the force vector, so F, and that is 300 minus 200, 150. Whoop. You see how mine turned red like that? It's because I forgot to put the first bracket on there. Blink. There we go. Okay. And then it was the x-axis. Okay. So I'm going to say AX is the axis of interest. Okay. And we're going to go 0. Whoops. No. 1, 0, 0. Like that. Okay. Now we haven't done anything yet except put in some information. Okay. So, but I'm going to go ahead and save it. So click save. And then I'm going to hit this green button, the green triangle over here, and that's going to run my program. All right. So I'm going to hit it. Okay. And I give me a message here. You probably got one like that too. And I'm just going to say add directory to load path. Okay. Boom. Just like that. Now, it doesn't look like anything happened because things only happen back here in the command window. Okay. So starting from here, all right, you can see it says moment about axis 1. Okay. So this is the name of our program. All right. This is the first vector we put in. Here's the force vector, and here's our axis. Okay. So it's going to put those things in there. 99.99% of the time, information like that, we are not interested in. So we don't need it to tell us that because it takes up a lot of space. Imagine if I had 50 different variables, I'd be burning up all this space just looking at those variables. Okay. So we're going to come back to the editor and we're going to put a semicolon behind each of our definitions. And the semicolon is how you tell Octave not to print that on the screen. Okay. Don't print that on the screen. So once I've done that and I run it again, I come back to my command window and it looks completely blank. Okay. So this is my second time running it, moment about axis 1, and it didn't output anything. Okay. And we might feel like, oh no, but watch this. If I go R, there it is. F, there it is. Okay. So it's in there. It's just not showing it to us. Okay. So let's come back to the editor. All right. We've got all that done. Yay. Okay. So let's find our moment. Okay. So our moment is going to be the cross product of R and F. Okay. And then what I'm going to do is first time out, I'm going to let it show it to us. Okay. But I'm going to hit tab. I'm going to go percent calculate the moment. Okay. So I used the percent. So this is I just put a comment on there. So this isn't going to do anything. It's just a note to me. I'm going to run it again. Come back to the command window. And there's M, just like we had before. Okay. So come back over here. Now, again, we don't really need that to see. We don't need to see that. So I'm going to put a semicolon on there, and that's going to take care of that. So it won't show us now. Okay. But now we need to find the amount of that. I don't know. Maybe it's useful to see. I'm going to renege on that. Okay. Now we need to find the amount of that in the direction of the axis of interest. Okay. So we're going to call it M underscore AX. Okay. So you can put an underscore in a variable name. It's no problem. Okay. And all we're going to do now is going to take the dot product of M and AX. Okay. I'm going to hit tab, make myself another note. Okay. Accumulate. This is like a projection. Okay. I'm going to save it. Haven't done that in a little bit. Hit my triangle. Come back to the command window. Ah, there we go. Boink, boink. Picked out the 24s. Okay. Piece of cake. Okay. All right. Let me pause here and make sure everybody's feeling pretty good about what we got so far. Okay. So, oh, Mary's got an error. Parse error near line 6. Frau Mensch.
Add to load path.
Um,
Add directory to load path.
What?
Nothing. Never mind.
Did you get it fixed, Mary?
I forgot the equal sign.
Oops. That would do it. Okay. So, now what we're going to do, okay, is if you remember then when we went to the second one here, okay, we were about the OA axis. Okay, not just the X axis. And we had to go through this stuff down here where we defined the axis, then we had to turn it into a unit vector, right? So we really need to do that. All right. So, where did my thing go? There it is. All right. So we're going to come up here and I'm going to say UAX. Okay. Now, right now, UAX doesn't exist. It's going to be the unit vector for AX. Okay. So we're going to do that. But before we do that, this is already, we got 1, 2, 3, 4, 5 variables. Okay. So let's leave some breadcrumbs for ourselves. Okay. So R is the moment arm. Okay. F is the force vector. Okay. And I'm going to make it look a little nicer. And AX is the axis of interest, like so. All right. So we need a unit vector. Okay. So we're going to do it in one. We could do it in little pieces, but we don't have to. Okay. We've got the computational power. We can do it in one shot. Okay. So I'm going to say UAX equals. Okay. So I'm going to have something times AX, and what I need times divided by AX. I need AX divided by its magnitude, right? So I need AX divided by square root of it dotted with itself, AX, comma AX, parenthesis, parenthesis. Okay. That should do it. Tab, comment. Okay. This is our unit vector, like this. Okay, so I'm gonna save it. We're gonna run it. And then I got to come back to the command window. Okay, here. All right. And MAX is 20. Okay. So UAX is just 100, which makes sense, right? Because it was a unit vector to begin with. Okay. And then we got our M. And so we're selecting out the 20. So it's this guy right here. Okay. So that worked out for us. Okay. All right. So let me look in the chat here. Gerardo, you're getting grays out all text in editor once I save it. Is it still doing that? Is it able to run? Like, does it have these things up here at the top? Your controls? Yeah, it runs. No, oh no, yeah, it's still doing it. No, it's not running. Okay. So let me do this. Okay. So I'm going to stop my screen share and I'm going to make it Gerardo. Please share your screen and I'll take a look at it. Okay, it's running right now. Hit that red circle up there. Try that. Okay, try the X over here. Maybe it's this guy. Oh, you can't see my cursor. Next one over. Yeah. What? Okay. Hit add directory to load path. Let's see what goes. Nope. Okay, try this. Control C. Go to your command window down here. I keep putting my mouse on it. I'm sorry. Oh, well, it's not doing anything there. Okay. Go back to the editor. Yeah.
If I delete it,
Okay, try it again. Let's do something real simple. After you type that, okay, now just, okay, hit return and go 3 plus 5 and run it.
once I save it.
Okay, it's going to overwrite what, okay. And turn that. Okay, all right. Okay, delete all that. Well, don't delete it. Don't delete it. Go hit save as again. Okay, now this time put underlines instead of dots. And save that. It still doesn't give you the green. Okay. Yeah, let's just try all that again. So get rid of that. Okay, now just go 3 plus 5. 3 plus 5 or something. Okay, and hit the green. Okay, try the underlines again. and go down to the command window. It should tell us 5 or 8. I'm glad it didn't tell us 5. We'd had a bigger problem. Okay. All right. Yeah. So there's the deal. All right. So I don't know if you were following along with that, guys, but Octave is very finicky with the names. Okay. And so when you were putting in those dots, it was interpreting that as something else. Okay. So it should run for you now. Okay. So always watch out for those names. Okay. All right, there you go. Okay. Can you go ahead and stop your share? All right. Terrific. Now I'll share. I'll go back to sharing. There we are. Okay. Okay. So let's do the last one that we did. Okay. Um, so we got to put the OA in there. So OA is 0.3, 0.40. So I want to do that. Okay. So I'm going to come up here. So all I have to do now is put 0.3, 0.40. Okay. And run it. Boom. And come back to the command window. And there we go. Minus 72, which is what we had before. Okay. Yeah, no problem, Gerardo. There's a lot of little subtle things. Lots of ways it can go wrong. Okay. So let me put the editor back up here. Okay. And again, I want, what point did you use for that OA, Mary? I used the exact vector that we used before. Okay. So how are we feeling with the octave part of this? Give me a number. Give me a number. Okay. Good. Tyler's got 5. 4, 5. Okay. Good. All right. Awesome. Okay. We can live with that. So here's what we're going to do. So we've got this fancy little program here. I want you to use our fancy little program to solve this one. Okay. So you can work with your neighbor. It gives us direction cosines there. So you may have to modify, unless you want to figure out the force vector, by hand, but you can modify our program a little bit to do that for you. But go ahead and work that out. It says solve the problem using both a scalar and a vector analysis. Don't do the scalar thing. We're not even going to bother with that. I haven't even showed you that. So we'll just go straight to vector analysis. Okay. All right. So set it up and figure out how to use our new shiny new Octave program to crank this dude out. All right. How'd you do with your program to get it altered? Okay. So I'm going to run it. All right. Go to the command window. Oop. There we go. Okay. So I got 17.426. Gerardo got 26.9. Uh-oh. Did I make an error in here? So R is 0/3 up 0.25. Okay, so this looks correct. And I got 200 on the cosine 120, cosine 60, cosine 45. Square root, do, cross product, cross product. Okay.
Oh, I just
Anybody
messed
else?
up with the F.
Sorry, what?
I just messed up with the F part.
Oh, this part here? Okay. Okay. You're getting creative. Okay. Let's see what else we got, guys. Well, let me say this now. How are we feeling overall with this stuff now? We had a lot of 3s and 4s earlier. I want to see how everybody's doing. Four and a half. There's one in every crowd. Okay, okay, okay. Let's look at another one. Let's look at another one. Okay. Okay. Everybody tried this one. Okay. And we're interested in the y-axis. Okay, so here we go. So when we do our moment arm, we need to go from there up to that point. Okay. So anywhere on that axis, this is the easiest place right here, just to come straight up like that. Okay. So there's our R. Okay. All right. So take it from there and try to give you a little bit of a head start. Okay. How'd you do to get your modifications? So I'm gonna hit run, see what we get. Go to command window. Boom. I got 210. Did you get it, Spencer? Was that celebration or annoyance?
Man, we're just confused.
Oh no. Okay.
Some of us are getting negative 210, some positive 210. It just.
It's okay. It's air. Oh,
Wait, so what?
oh, it's water.
Did you do your cross product backwards? So here's R. So if you put the R in backwards, then you'll get a negative 210 for sure. There.
Why'd you put 0 for your Y? For your R?
Because let me get rid of that first. I'll come here. Okay. Because the X, this is the XZ plane. All right. So it's over here at 4. It's still over here at 4. Okay. It hasn't moved in the Y direction going from here to here.
Okay.
Spencer have a breakthrough? Do you have a breakthrough? We've been working hard on this for several weeks now, you know. Sometimes these things take a while to process, but hopefully you had a breakthrough. That's good. That's good.
I think we've ascended. Like honestly, I think our brains have ascended a level.
Your
We're learning
brain's
all this.
ascended level. Okay.
Yes.
Very good.
Yeah.
Very good. Okay, I want to do at least one more. Okay, so everybody can feel a little more, hopefully a little more comfortable with how all this works. Okay. Okay, now on this one, our program is going to do more than we need it to. So we don't really need everything that's in our program. So we'll just sort of ignore some of those things. Okay. But we want to do this just like we did the others, okay, which is let's first figure out our axis of interest, and it is right along here. Okay. Now what it says is determine the moment of the force about the AB axis. Okay. So we want to have that guy right there is going to be R for us. Okay. So let's go from B to A. All right. It says AB axis, but I don't know that it matters. We'll see. It might turn out to be different by a negative sign. So if we get through all of this and turns out that you're off by a negative sign, it's just because of that. Okay, it doesn't really matter. All right. So R is going to be it's not going anywhere in X, it's not going anywhere in Y, only in Z it's going up 2. Okay. And I'm going to renege on what I just said because I bet your book has done the calculation going from A to B. So let's do it that way as well. Okay. God, that I really don't like that though. I'm gonna renege on my reneging. That bugs me. Okay, we're not going anywhere in Z, but in A, we're gonna come forward 4 in X. And we're gonna go backwards 3 in Y, and we got a 0 here. Okay, so let me come over to my program. Okay, let's make these modifications. There's that. F is 50, 40, 20. There we go. Now, axis of interest, we said was 4 minus 3 and 0. Okay, so that's all I had to do there. And remember, our it's going to tell us what M is. It's going to tell us what the component of M along AB is. Okay, so I'm going to run this baby. Come to the command window. There we go. We got 0.8 minus 0.6. Okay, 80. Okay, so we got 4. So that's all we got. Not a lot. Not a lot. Okay. AB magnitude is 5. Yeah. I got 4. How'd you get 4? Well, it's a 3, 4, 5 triangle. You got the magnitude of AB is 5 in your program, or
Using the Pythagorean theorem, I got the mag is 5, but in the program, it ran it as 4.
so like what I'm showing right here, is that what you have? MAX equal 4? Got it. Okay. Well, that is not the magnitude of AB. That is the magnitude of the component of M along AB. So that's why it's different. Okay. Does that make sense? Okay, great. Okay. So now here's the thing though. We haven't actually answered the question because it says express the result as a Cartesian vector. It's like, wait, what? Everything we've done so far is a scalar. Now it says the moment about AB, but it doesn't say the magnitude of it. Okay. What we've computed is the magnitude, but that's okay because all we have to do is take the magnitude of that projection and work it with the unit vector. So we got that number 4, okay, for the answer, okay, but that is only the length of it, okay. So we're just going to come back to the editor here. We've got the projection, okay. So now we're just going to make, we're just going to call it MAX. And that's going to be different than with the underline in it. Okay. And we're just going to take M underline AX, multiply it by our unit vector AX, like so. Okay. Now I might have to come back up here and remind ourselves that this is a magnitude. And then let's make a note for ourselves here. Okay, that this is the vector projection. Like so. Wait. There we go. Good. All right. Good job. Mary, you got it there. 3.2 and minus 2.4. Good. So it's a vector quantity this time, Mary. So instead of just, yeah, instead of what we had before, which was just how much is in that direction, now we've turned it into how much and in what direction by making it a full vector. Okay.
We meeting back today.
What?
Are we meeting back today?
What?
There we go.
Sometimes. Are we meeting back today?
Oh, no, no, no. We're going to be done here in just a second. Yeah. So I'm going to give you the afternoon to
Sounds like
go
early working.
work on these. So, yeah. Anyone want to ask any, but that's the last one I want to look at. I think my blood sugar's dropping and I think everybody's looking tired and like their brain is at capacity. So, last minute questions before we bug out of here. Anyone?
I have one. So is Octave like required for this class, or is it because I have a Mac and I can't seem to get it to download on it? So, or like, do you think I can do it without it?
No, it's not required. Have you tried the online version?
Yeah, and like I was trying it and I couldn't find edit and I couldn't find anywhere to like save something.
Yeah, give me just a second here. Can I
Yeah,
tell you
honest
what?
to God, I've been cheating using MATLAB like the whole time just because I still have it downloaded from when I went to university. So I've been
That's
doing
okay.
that.
And you got it on your Mac?
Yeah.
That's fine. Yeah. So okay, so I tell you what. So Marcelo, you hang out for just a second. Everybody else, you're free to go, and I'll see you back here online on Wednesday. Okay. So we're gonna take a look at this. I'm gonna do it a little different.
So we're having a very short day today, right? Or am I mistaken?
Well, let's not say it that way. Let's say that what you're doing this afternoon is working remotely.
Hold on a minute, guys. I can't hear him. What'd you say, Mr. Cordery?
I said, think of it as working remotely.
Okay. Well,
So
then I
you're
will see you on Wednesday then.
okay. Sounds good. Bye, Mary.
All right.
Bye.
Okay. So
Great to meet.
what I'm gonna do, let's see here. Okay. Okay. So this is the Octave Online. Is this the one you've been looking at? Oh, I can't. You're muted.
Yeah. Um, I it is, but I think it's a little bit different because I'm signed in. But I mean, it looks basically just like that. Yeah.
Yeah.
You mean
like So-
we're having trouble with these things?
If we look at the menu, well, that's not helpful.
And I've got a couple of the other ones.
So if we got like A equals 3, B equals 4, A plus B 7. Okay. So I'm not signed in. We're not plotting anything there. Okay. So I'm gonna have to kind of play with this a little bit. And now that I've done this, how do I sign in? Oh, sign in. Okay. Welcome. It's been a while, has it? Okay. All right. So we got some stuff. Okay. So what you're seeing, does it look like this?
Yes, exactly.
Okay. So this is the command prompt. Right. So how do we do a script? Oh. I think up here, files, let's hit the plus. My script, that's fine. I'm just going to call it my script for now. Okay. Click on that. There we go. So I clicked on it on the name and it gave me this. So now I can go A equal 3, B equal 6, go A plus B and hit run. And why didn't it tell us? Let's try it again. Save it. Now we're going to run it. Okay. So we have to save it every time.
Okay.
Okay. So now here's where you can put all that stuff we did.
And so up there, my script, that's the name of it.
Well, that's a default name. Yeah. Which you
Okay.
could change that or whatever. So you're going to
Okay.
want to do add file here, drop files here to upload, that kind of thing. So
Okay.
let's try this. If you got just a second.
Yeah, I do.
Okay. Okay. So what I'm going to try to do here is I got a lot of stuff going on here. Okay. So I'm going to try and grab the thing we just did. MATLAB, practice. here. I copy this. Okay. And I want to send it to you in an email. Do you have an email? I know you have an email, but
Yeah.
okay. Give me just a second here.
You good?
Oh, okay. I'll do it from my work email so you know it's me. Okay.
Okay. Do you need my like WS email or any email work?
Whatever's most convenient right now, because I want you to be
Okay.
able to pull it out and upload it. So you
Okay.
just let me know. All right. What should I do?
M Vargas. Well, okay. MVARGAS 3455 at gmail.com. M Vargas 3455 at gmail.com.
Okay. It looks like you've emailed me before, probably. I just have forgotten. Okay. So it's just going to say M file. And then okay. So I just sent it to you. So theoretically, you should be able to drag it here where it says drop files here to upload.
Okay.
And let's see if that works.
Let's see here.
I'm going to ask her I'm going to ask her about eating lunch. After I eat lunch, about why do we have to build these questions from the ground up? No, it's the learning you do the algebra. You know, you only do the algebra. Oh, you know,
I'll try it too. Oh yeah, that was pretty sweet.
You get it?
Yeah, I literally just dragged it into that little space over there, and I'm looking at it right here.
There's so much algebra. When you give me a question, when you're asking, how do you put it in these terms? You confuse the P out of it. But I mean, if I go back to here, I figured out. I missed this stuff up to the pressure, but every other piece I have to figure out. Which is, we started by number two.
Do you think you just a second. Do you think you could send it to another email actually?
Yeah.
Okay. Because I don't know why, but this one's not working.
Okay. I'm ready.
Okay, let's do MJ Vargas at senators.ws.edu.
All righty. Okay, I'm also going to call it M file. Okay, so I sent it, so hopefully you'll be getting it momentarily.
Well, I mean, at this point over here is getting 2/3 of the minute. This one's getting only 1/3. Yeah. And you can tell if you want to say FP is like if I had the numbers, I could figure probably out the answer really easy. No, when you're asking just on time, it is algebra. I'm just going to ask her about all those questions. Question 1, 6.
Did you get it?
8, 9.
I'm working on it. I'm not that good with computers.
Just pure algebra in front of me. That was
let's see.
Go ahead.
Okay, M file.
But it's just like, when you throw pure algebra in my face, you basically just do it. And there's one where it's like, that.
Oh, yeah, this one. I calculated it as 1.4. It makes no sense.
Let's see.
The answer is no.
But it's just like, I was looking at it and I was like, I got that one going, how are you supposed to calculate this? Because you've got a math from this side.
How do you drag it from your email to?
You'll need to save it on your computer.
Okay.
I got it wrong. I got 1.75.
So, okay. And then, oh wait, let's see.
Well, you got one down. I'm gonna have to ask her about that one.
Okay, I think I did it.
Okay.
So it's over there in the files now, and then what do you
And then
do?
just click on it. Moment about axis.
An equation to a certain point. Why? Because I mean, technically you could represent this as a beam with 0.67 kilograms in this end. And it's really cool.
Wait, mine doesn't look like that for some reason.
No?
No, I click on it, but it doesn't show anything really.
Huh. Well, I'm going to stop my share and then you share your screen with me, okay?
Okay.
I'm gonna talk to her and chat with her, and then I'm gonna figure out the rest of this algebra. Why, look at that, why is there so? What's the look at that? Just ugly, and I just got it wrong with that. It's ugly, and this is, and that's the part which I use.
Have you ever shared
I
before?
think it says I have to allow it in my settings, so I have to quit and reopen Zoom, but I'll be right back, okay?
Okay. I'll be here.
Fair.
I think I have 2 laps.
Okay.
Once I'm getting a bit late.
Can you see it?
But most of the time,
Wait.
Yeah, I can see your screen now. Yeah.
Okay.
But anyways,
Let's see.
after doing that, I had the last 2.
Like if I click on it, it doesn't do anything. Do you want here? I'll drag it over.
It looks
Oh,
it
wait.
looks like you need to log back in or something. I don't know. Says you lost your connection or something.
Okay, let me sign out and then sign back in.
Good idea. Good idea. Oh my goodness.
Yeah, I'm doing this. I'll see you guys. this is taking so long.
That's all right. Well, we'll get this set up and then you'll be good to go.
Okay, let me drag it again and see what happens.
Let's try that, yeah.
Crap.
Do you have MATLAB?
No, I was trying to get it, but it costs a lot of money.
Uh-huh.
And I just click on it and nothing happens for some reason.
Oh, that's weird.
I don't know.
You might need to send them, contact tech support or something. Be like, hey,
Yeah, yeah,
um,
that's probably what I'll do.
what is that? You see there's like the two arrows in between, um, over on the left
Um,
where they're like make like a circly thing, like it's refresh or something.
this will reload your files. Okay.
Okay, and now try clicking on one of those again.
No.
Huh. So where is that file at? I mean, how did you?
Where is it now? I did this and then I just press download and then it goes up
And it went to your
to there.
OneDrive?
No, I just downloaded it on my Mac.
Okay. So then where's your like folder
And then
management?
I did it like it shows downloads up there. Can you see that? And then
Yeah.
there's that, and then you can just drag stuff like that.
Okay. Yeah,
Yeah,
gosh, I don't know what the deal is there, man. I'm sorry.
yeah, it's all right.
Check with the it looks like they probably have pretty good tech support. And I bet if you go out, I bet if you Google, you know, Octave online support, you're probably going to find like some chats and some forums, and you're going to find some people that are like totally nerdy about that, and they'll have all kinds of answers.
Yeah, yeah, I'll try that. But thank you
Okay.
for help. Thank you for trying, anyways.
Yeah, and
Yeah.
let me know. Okay, you get that squared away because that's going to save you a bunch of time.
Okay, I will.
Okay,
But thank you.
see ya.
Yeah. See ya.